Hello everyone. In this series, I'll walk through how enterprises can secure modern AI-driven workflows across both public and private LLM environments. We'll cover this in 3 parts. Part 1 focuses on securing workflows using MCP with public LLM, where I'll demo MCP client-server communication using Gemini. Part 2 explores how Zscaler AI Guardrail protects interaction between AI agent and public LLM by enforcing prompt and response detectors. And in Part 3, you will see how Zscaler AI Guard extends the same protection to private LLMs, using Light LLM as proxy layer between the agent and the private model. In this video, we'll discuss the AI security challenges with traditional DLP and CASB solutions. I'll demonstrate the interaction between the MCP client and server to retrieve data, followed by the redaction of sensitive information to ensure only sanitized results are saved. Traditionally, we secured applications using DLP and CASB techniques. However, these were built for structured data flows and file movement, and they are increasingly insufficient in an AI-driven world. Legacy tools create critical blind spots. Traditional DLP focuses on file movement, upload-download, and pattern matching using regular expressions and hashes. AI agents don't move files. They extract the semantic content or the meaning of a document and send it as a free-form prompt. This creates a blind spot. Traditional DLP sees 0 files transferred, resulting in 0% detection for contextual or prompt-level leaks. Legacy CASB acts as a static gatekeeper based on app URLs and API hooks, for example, allow box or block Dropbox. In AI era, SaaS apps now have embedded AI and MCP servers that bridge different clouds autonomously. Traditional CASB has no intent-based visibility. It cannot distinguish between a standard file save and an AI agent reading that same file via an MCP connection. Traditional security focused on protecting data at rest and data in motion. In AI era, AI creates summaries, code, and derived content. PII or IP may be present in a model's generated response. Legacy tools have no mechanism to prevent context leakage in real time as the agent creates new data. We can no longer just look for a specific file being uploaded. In the AI era, security must understand intent. Instead of searching for a hash, our security layer now performs a semantic check. It asks, is the AI agent attempting to extract PII from this context? Even if the data is transformed or summarized, the security proxy recognizes the underlying sensitive meaning. Because AI agents use MCP to move between AI apps, we need a context-aware gatekeeper. In my upcoming demo, you'll see how the security layer monitors the agent's actions. The requested information was provided, but the sensitive data was redacted. Finally, we are moving from data at rest to data in generation. Traditional tools can't stop an AI from typing a secret. In the demo, you'll see how the model's response acts as a real-time filter. It intercepts and masks sensitive data dynamically. For this demo, I'll use Gemini Agent, which also acts as the MCP client. The client connects to SaaS applications like Box and GitHub, which have built-in MCP server running. Box is our source, where the raw data containing sensitive information resides. GitHub serves as our audit repository where sanitized data will be securely stored. I'll issue a prompt requesting information about a specific user from Box, redact sensitive information, and then save the sanitized result to GitHub. MCP servers expose your resources and tool sets that the agent can securely access and execute. By using MCP, the agent does not require custom integrations for every application. It only needs a standardized protocol to interact with tools securely and consistently. The agent invokes read call to retrieve the raw data from Box MCP server. PI information from the raw data is redacted as per prompt instructions. And finally, the agent invokes the MCP action to save the redacted information into the GitHub public repository. So let's hop on and get to the fun part, seeing things in action. This is my Gemini agent. These are the MCP servers that the client is connected to, the Box and the GitHub MCP servers. These are the tools available that the client can use. Here are the resources which contain sensitive information. Here's the box file, which has PII data. Here's my Git repo, which is currently empty. So we'll issue a prompt that we need data for this user Susan Davis, which is located in our box file. We have requested that we need the data, and it needs to be redacted before it is saved onto the Git repo. Let's take a closer look of what happened. The client first made a read call to the Box MCP server. Client got the raw data on which redaction was performed. Finally, client made the update call to the Git MCP server to save the sanitized result to the Git repo. So let's verify our Git repo. So as you could see, this is the data that we requested, and the PII information is redacted. Note that in this flow, Box MCP server sent the raw data including sensitive info. Redaction was performed before the sanitized result was written to Git. Let's try a few additional prompts. Let's trigger a prompt to get financial advice. Here is an additional prompt for retrieving Cisco product information. The agent receives response for both queries. And finally, check which LLM the agent is using. The agent confirms it utilizes the Google-trained public LLM. Due to data residency and compliance requirements, some organizations restrict agents from communicating directly with public LLM to prevent the exposure of PII. In the second part of this series, we'll demonstrate how to solve this by implementing a security guardrail between the agent and the public LLM. To recap, we covered the challenges as traditional DLP and CASB tools look at files, patterns, or API calls. But AI doesn't move files, it extracts meaning. In AI era, the security shifts from protecting static data to monitoring data in generation, ensuring real-time intent-based checks. Finally, we saw in action how PII data was sanitized and safely stored in GitHub. While the workflow is fully standardized, no custom connectors needed. To continue the series, watch the next videos where we add AI guardrails to further secure the workflow and extend protection across both public and private LLM environments. Thank you for watching, and don't forget to subscribe. Your support means a lot.